Hey Scott, I'm going to send the calibrator down to you, so I thought I would just quickly run through how it works. I know you'll suss it out real fast, but I'll just show you anyway. So I've put a 1600 kPa analog gauge onto the manifold, and this is your main screen. The most common way for doing a calibration is to do tasks. We can just type in a pressure and it will go to it. So for example, if I type in 200 kPa, it will automatically pressure to 200 kPa. But of course that's not a full the normal method of operation is to do a task which you set up as a calibration. But just to show you, there it is, the green indicates that it's stable. But what we'll do, we'll vent, and I'll show you how you set up a task to calibrate this gauge. Okay, the menu button up here on the right, and you select task. There's a list of tasks that we've been working on. I'll hit plus, and we'll do a new task, and here we have a choice of dial pressure gauge, digital pressure gauge, etc., etc. So this is a dial pressure gauge, of course. So we'll call this one Scott. Oh, I already tried this, so it's Scott 1. That's fine. Serial number if you want it. Location, so you could put, the homogenizer or whatever you're doing. Notes, so if you wanted to put any notes about, this is a liquid filled gauge and it was replaced on this day or whatever. Gauge pressure, absolute pressure or differential. We want gauge pressure, of course. This gauge is a 0 to 1600 kPa. It's a dual scale. It also has pound inches, pound squared inches, and you could just as easily, if you select that, you could change that unit of measure to anything you want, from pascals through imperial, but we'll stick with kPa. And we've effectively done the main calibration setup. So let's select Scott, and now we can, one other choice we have is the number of calibration points or cardinal points you want to use. At the moment it's got five calibration points. Probably for the sake of doing a demo, I'll make it less to make it quicker. So right now it's showing 0, 400, 800, 1200 and 1600 kPa. Let's make it 3, just for a fast test. You probably wouldn't do as few as 3. So now it will just test at 0, at 800 and 1600 kPa, and then on falling as well. Okay, down the bottom here we have a start button, a play button. If we had a 4 to 20 milliamp device that could give feedback, there would be a M for manual and then an A for auto. But because we have no feedback, obviously we have to manually say what the range is. We've just got manual. So it starts at 0. You'll see it draws a graph. So at 0, we agree that it's reading 0. So now we're going to 800 kPa. And again, this number will change to green once we have a stable reading. And of course on the analog gauge we're heading for 800. Okay, it's green, so it's stable. Our analog gauge is reading, let's pretend it's out on purpose just to show you. So I'm going to type in that it actually reads 795. It's not, it's reading 800. Now we're going to 1600. Eventually. So there we are. We can see it's green, it's stable, 1600, and we've got 1600 here. Again, we'll imagine that we had a poor reading on here. Let's say we had 1590, sake of argument. Now, it will repeat the test on falling. So now we're going to drop to 800 kPa. Okay, it's stable, and we'll accept that reading. It actually is 800 kPa. And now we'll go to 0. And yep, we're happy. We've got a 0. And now we have a graph. So we can see, because of the fact that we deliberately put some bad readings in, we can see we have a fail on rising, but a pass on falling. And there's your acceptable parameters. We could save that now, send it to the PC, and do a certificate.